Welcome students, I am Dr. Kim Rodriguez, Assistant Professor in Botany at Kamal College of Arts, Science and Commerce for Women, Nouvelle Goa. Today I will be teaching Rhizobium as biofertilizer for 3rd year BSc Botany Semester 6 students. Course code BOD 104, course title Biofertilizers. The title of the unit is Unit 2 Symbiotic Nitrogen Fixing Microbes. Module name Rhizobium as Biofertilizer 2. The module outline is Production of Carrier-Based Inoculants, Techniques of Field Application, Crop Response. The learning outcomes of the module are describes the production of Rhizobium carrier-based inoculants, explains the techniques of field application of Rhizobium carrier-based inoculants and its response on crops. In the previous module, Rhizobium as Biofertilizer 1, we studied the root nodule symbiosis, isolation, identification, and mass multiplication of Rhizobium. In this module, we are going to study the production of carrier-based inoculants of Rhizobium, techniques of field application of Rhizobium carrier-based inoculants, and its response on crops. Rhizobium as biofertilizer. Rhizobial biofertilizers can be carrier-based inoculants, agar-based inoculant, broth culture, and dried culture. New developments in biofertilizer productions are freeze-dried inoculants, Rhizobium paste, granular inoculant, pelleting, polyacrylamide entrapped rhizobia, and pre-coated seeds appear to be more promising for inoculation success in tropical legumes. Carrier-based inoculant has been regarded as more suitable for commercial purposes. Production of carrier-based inoculants. A variety of carriers are used for rhizobial inoculants like peat, lignite, farmyard manure, charcoal powder, etc. Carrier is powdered and dried in sun to get 5% moisture level. The carrier is then screened through mesh sieve and neutralized by mixing with calcium carbonate powder. It is sterilized by autoclaving at 15 psi for 3 hours and dried. The harvested broth is mixed with carrier. The moisture content should be about 35 to 40% dry weight. Carrier containing inoculant is left for 2 to 10 days at 22 to 24 degrees Celsius. During this process, Rhizobium multiplies. This is the curing process. Rhizobial count should be 3 into 10 raised to 8 cells per gram of carrier. Rhizobium inoculant can be used directly or packed and stored. Packing and storage. Cured carrier-based inoculants are packed in polythene bags and kept at a constant room temperature for about a week to facilitate the rhizobial cells to get established. Bags should be stored at 4 to 15 degrees Celsius in a cold room so that rhizobial cells may remain viable for more than 6 months. Bags should not directly be exposed to sunlight or heat, otherwise rhizobial cells will be killed. Techniques of field application. Seed treatment or inoculation with carrier-based inoculant. 50 grams cane sugar is dissolved in 500 ml of water and boiled for 15 minutes, followed by adding 200 grams of gum arabic to the boiling solution and stir well, cool. This is the sticker solution. We then add 200 grams of carrier-based rhizobium inoculant into sticker solution and mix it well to get the biofertilizer slurry. We then add seeds of a legume into the slurry, mix well by hands. This results in about 10 raised to 5 to 10 raised to 6 rhizobial cells getting adsorbed on each seed. Dry the seeds by spreading on a polythene sheet in shade. Sow the seeds coated with rhizobial cells in the field. Pelleting. When soil has adverse conditions such as dryness, acidity, excess fertilizers and pesticides, the rhizobial cells are protected by adopting a special method of inoculation, that is, pelleting or preparation of pelleted seeds. This method is similar to seed treatment, but high amount of gum arabic, that is 40%, is added to the inoculum slurry. Finally, a pelleting agent such as calcium carbonate, rock phosphate, charcoal powder, gypsum, bentonite is mixed when inoculated seeds are moist before seed drying. Sometimes the inoculum is stored at 4 degrees Celsius. Stored inoculum is sprayed over the soil directly to improve the soil fertility. Crop response. Seed inoculation of a proper Rhizobium strain increases growth and yield of many legumes. Rhizobium usually increases the yield of legumes up to 10 to 35%. In Cajanus cajan, it increases in yield up to 4 to 40%. In Sisa eritinum, it boosts yield up to 4 to 67%. In Vigna mungo, it increases the yield up to 4 to 29%. And in Lens culinaris, it improves the yield up to 21%. Crop rotation of Rhizobium inoculated legumes with cereals increases the yield of the subsequent cereal crop. Crop rotation of Cajanus cajan with Triticum aestivum increases the wheat yield up to 16.4%. Crop rotation of Lens culinaris with Oryza sativa has increased the rice yield up to 13.2%. To summarize, Rhizobium biofertilizer in the form of carrier-based inoculant has been regarded as most suitable for commercial purposes. A variety of carrier materials are used for rhizobial inoculants like peat, lignite, farmyard manure, charcoal powder, etc. Good quality of carrier-based inoculant is that which contains sufficient amount of rhizobial cells, that is 3 into 10 raised to 8 cells per gram of carrier. Rhizobium as biofertilizer helps to improve soil fertility, plant nutrition and growth. These are some of the references. Thank you.